What's up, ladies and gentlemen? FFDev here, and in this series, or in this video, I should say, we're going to be continuing on to the Pong game. This is video 2. So first thing we're going to do is we're going to fix our window where we can click the X and close the window. It's not even a big deal to implement, but I just didn't do it last time because we were getting on a pretty lengthy video. So you want to create an SF event. Let me cut this here. We don't want it here. We want this above our while window is open loop. We want to put it under the delta time. We'll do it there. SF event, we're going to name it event in lower cases. And then right here, I'm going to put above the keyboard is key pressed escape. We're going to say while window dot poll event. Plug that as the parameters. We're going to say if event dot type is equal to SF event closed, like that. Then we're just going to say window dot close, and that's all there is to it. And so now whenever we start our little game up here, should be able to just click on the X and close it. Alright, without further ado though, we're going to create the paddle class. So if you want to right click on source, add class, we're going to name it paddle. I'm going to put it with a capital P. And now that we have our paddles here, paddle.cpp and paddle.h, we're going to drag it into our source folder, or src, and then click on OK. Now that's on there, we're going to go to our paddle header here, double click it. Alright. Now that we're in the paddle header, we're going to include SFML / graphics.hppp. And what we're going to do first is I'm just going to go ahead and put private, keep our code nice, neat, and organized. First thing we're going to declare is a SF, let's say, can't even think right. I actually did this whole video and didn't realize my mic was unplugged. We're going to declare a rect shape called my M shape. Next we're going to declare a vector2f, SF vector2f, m underscore dot position. And then after that, we're going to declare a float called m underscore speed. We're going to initialize that to, let's see, 1100. And I'm just going to put .0f just to keep it consistent with the syntax. After that, also, we're going to need a bool called m moving left equals false. Then we're going to create another bool, m moving right equals false. And it takes a little bit of time and thinking to get these things created. I've just already done this, didn't record it. So for our functions now, we're going to need to get the shape. So we're going to put SF rectangle shape get shape. Then we're going to type in SF, let's see, float rect called get position. Then we're also going to need a let's see, void move left, void move right, void stop left, and void stop right. And also we're going to need a void update function which takes in SF time dt. It's going to take in a delta time variant. And one other thing I forgot it needs to be public is the constructor. So paddle, and it's going to take in a float start x and float start y. Now we got all this created, we can go over to our paddle.cpp file. We can get started creating this. So first thing we're going to do is our constructor, paddle, and we're going to say float start x, float start y. And we're gonna initialize this to m position dot x equals start x, and m position dot y equals start y. Next, we're gonna before we fully fix this, we're gonna go ahead and give this some parameters. So we're gonna say paddle, or no, m underscore shape dot set size. We're gonna put this to 50. We'll have to put a SF vector to f. 55. It's 50 on the x, 5 on the y. Then we're gonna put the m shape dot set fill color. I'm gonna set it's the SF color red. You can put it to whatever color you want. It's your project. Having trouble getting the shape to go. Alright, it doesn't want to show it. So m shape dot, let's say set dot, what's it doing? Outline color. Something on this does not want to run right. I don't know what was up with it. Set outline color. But it's working now after I delete it to SF color white. Alright, and then we're going to set the M shape dot set outline thickness to, we're just going to set this to 3. Now our paddle should be red in the middle and white on the outside, or whatever color you set it. And the last thing we're going to do is M shape dot set, I don't know why it's doing this, shape dot set position, I think it's a glitch, to M position. Alright, that's our constructor here. Next thing we're going to need to do is we're going to need to put a few more parameters up. Let's save. Let's see, SF float rec paddle, gotta be a capital P there. Get position. It's going to return M shape dot get global bounds. Then type in SF rectangle shape paddle get shape. And in here, all it's going to do is it's going to return the M shape. Alright, and the other stuff's going to be pretty straightforward. Void paddle, let's say move left. All this is going to do is it's going to set M moving left equals true. And we're going to do the same with the right one. Now we're going to do two more functions called void paddle stop left, and it's just going to set it to false. And moving left is false, then the stop right is going to set the right to false. And then we're going to do our update function. It's going to take an SF void update. It's going to take in a time dt. And what it's going to say is m position. Or it's actually going to say if m moving left. I don't know why it's wanting to be so. Why it's giving me such a hard time. Oh my goodness. I do not know why this one to be so difficult. Oh, I see the problem. I see the problem. Because we didn't put the paddle, let it know it's part of the paddle function. There we go. I was just using that to debug. So now we're going to say if m moving left, which means if that's true, we're going to say m position dot x minus equals m speed times dt dot s seconds. And now we're going to say if m moving right, we're going to say m position dot x plus equals m speed times dt s seconds. Alright, and what we're always going to do though, it's going to be m shape dot set position to m underscore position. Whew. That's a lot to say. Alright, so now we're going to go to our main function. And we're just going to want to declare our paddle, so we're going to name it. We're going to want to include the header file first, I guess, so we can use our paddle. Just going to do this one thing at a time. Include paddle.h. And so we're going to name this paddle my paddle. And we're going to put it at 1280 divided by 2, so it's center. And I'm going to say, since the bottom starts, since the bottom is where, you know, the highest number, and the top is the lowest, so since the very bottom is going to be 720, I'm going to say we put this at about 715. 5 pixels up, and that should put it right at the bottom. And if we don't like that, we can always change it. So now all we want to do first is my paddle dot update, plug in dt, and then we're going to put my, let's see, window dot draw my paddle dot get shape. And if everything works correctly, we should see your paddle on the screen now. Everything didn't work correctly. Oh. Return. What a simple mistake. It's easy to make these simple mistakes. Alright, we see our paddle there, and it definitely needs to be moved up some. So how we'll start this is we'll put this to 710. We'll try that on our paddle. Y coordinates. Alright, that looks about perfect. Now we just need to be able to move our paddle. So we'll say if SF keyboard is key pressed, SF keyboard A, we're going to say my paddle dot move left. And then we're going to add an else statement, which means else if it's not moving left, we're going to say my paddle dot stop left. Now we're going to do the same thing with move right. So it's if SF keyboard is key pressed. I'm going to say SF keyboard, and we're going to use the D key. My paddle dot move right. And you guessed it. We're going to add an else statement below it. And we're going to say my paddle dot stop right. Now, if that works, we're just going to be able to hit our keys, and there we go. You see we can move our paddle now, but it's not hitting the ball. The ball's going right through it. So what we'll do now, so we're going to check for collision. So this is pretty easy. We'll just add an if statement. Let's say if my ball dot get position dot intersects, and then in this we're going to add in my paddle dot get position. Then we're going to add in, let's say let's see, my ball dot hit ball. We're going to run that function. We can do more to this later. And you should be seeing like a little bit of you should see a few glitches here and there. Like there's actually a chance that this can mess up and can run too many times. Or the ball can kind of bounce around. You see how it kind of stuck to the roof and stuck to the paddle there? We're going to stop that from happening. And how it stuck to the paddle. The reason why it's doing this is because we're having a really high frame rate, and when it intersects it, it's already running the code again before the ball leaves the paddle. So if it's leaving, it can automatically start sticking because it's counting as it's being hit and it's reflipping the direction. So what we're going to do is we're going to add a timer on how long that event can be called. So we're going to say float, and we're just going to call this bounce timer, and we're going to initialize it to 0.10 F. And then right here we're going to say bounce timer minus equals dt dot as seconds. So this is going to count down as seconds. It's going to subtract it, and all we got to do is we just got to say, where is it at? Intersects, and we're just going to say I could just put it in here in the condition, but I could just put it here, and we can say if bounce timer is less than 0, then we're going to want to run this function, and then we're going to say bounce timer equals 0.10 F. And there's also a way we could have put this condition in the top of the function, but either way is fine. So now we're also going to want to do that where if it bounces at the bottom, and we're going to add that in the top. We're going to do a different way. So let's say, or it bounces off the top if it's less than that. And alright, had to take a short break, had something going on. Alright, so we're also going to add the timer here at the bounce top. So what we're going to do is if my ball.getPosition.top, is less than 0, we're going to say and bounce timer is less than 0. Then we're going to add this right here to the code. Bounce timer equals 0.10f. Now when we run this code, everything should work perfectly fine, and we're not going to have it sticking on anything anymore. And that's how you want to do it on some things. You're going to learn that in coding, is you just want to, you know, sometimes you want to limit how fast a function or something can run. Alright, so I think that's about all we're going to do in this little tutorial here. If you like this video so far, you like this series, hit the like button, subscribe, comment below on what you want to see. And also, there's going to be a part 3, and in that part, I'm going to be showing, like, we're going to be adding the UI, a scoring system, and all that stuff, so you'll have a fully complete game. Not sure if I'll really worry about sound. I might find some sound for you, or at least show you how to add it. But see you guys in the next video. Take care.